Okay, so I'm going to show you and talk about how this glitch item 8F works, which is used for arbitrary code execution in Pokémon Red and Blue. It's a really powerful item and really cool. So when we use 8F, well, first off, when we use any item, it basically calls a certain function for that item. And the way that it knows which function to call is there's a big table in memory of which functions to call, when you use a certain item. Basically, there's a certain pointer that gets used to jump to execution to a certain spot in the code. Now, those pointers are calculated as offsets from the beginning of the list based on the item's ID. Now, the glitch items have IDs that point such that they point beyond that table in memory to erroneous parts of memory that were never intended to be used with items, because their item ID is too large, but these items still exist. So it happens to be that when we use 8F, this jumps the execution to where our party Pokemon are stored at, party, right here, to D163, number of Pokemon in our party. And so basically, it's going to jump execution here and then read whatever data are in at these addresses and interpret that as opcodes for Game Boy instructions. So what we can do then is set up our Pokemon in a very specific way. If we have a Pidgey, Parasect, Onyx, Tentacool, Kangaskhan, and specifically a Pidgey with 233 HP, because that's what the next Pokemon, or that's what the next bytes in memory are. This is a small program that will jump execution to the third slot in our item bag, which is D322, right here. And so it'll start executing all these bytes in memory where our items are stored, their values and their quantity, as code, as instructions. So currently here we have, this is where it starts, D31D. This is the number of items in our bag. This is the Pokédoll. This is the 8F, quantity 1. Then this is Carbos, quantity D5, hex D5. So why is it that? If we look at Carbos in the big hex list, which shows the hex value, the ID and how that ID is interpreted in different contexts. So it can represent a certain Pokemon, or it can represent a certain item, or it can be an instruction. They're all the same. There's no difference between data and code. It's all just bytes. So if we look at Carbos, and it'll be the second one, right here, has value 26, just like here, and that corresponds to a load H instruction. So H is a register, and it's going to read the next byte and load that into H. So that's why we have the quantity set specifically. That's a D5. And then 2E, if we look at 2E here, 2E we see is our X accuracy right here, and we have 59 of them. That corresponds to a load L instruction. So Carbos and X accuracy together are a load HL instruction, and the value it loads into each of those registers is the quantity of that item. So this will be load H D5, load L 3B. So this will jump execution to D5 3B, because TM33 is not that one, it's the next one, E9, TM33 is a JPHL, a jump HL, so it'll jump execution to what we stored in HL, which again is D53B. Now if we look back at our RAM, what is in D53B? D53B, this is where our items are stored in our PC. So we're this is called a bootstrap, where we're writing one piece of code to jump execution to another area of memory that gives us a larger bank of addresses to write a payload. And so let's go and look at, let's not use 8F yet, let's go and look at what's stored in our PC. Because whatever is in here is going to be executed as code. So these items and quantities, this is a much bigger program than we could easily write in our item bag. Okay, so let's just see what that does. Let's execute 8F. Remember, so just to reiterate, it's going to jump execution to our party Pokemon, read through our list of Pokemon. At the end of that, it'll jump to our item bag. It'll read the Carbos, X accuracy, and TM33, which is a jump HL instruction that'll move the program counter to D53B, which are where our items are stored in our PC, and then it'll run that code. And look at this, it's showing an address and a value. This is actually a memory writer that someone has programmed. I forget their name, I think it's ZZAAZZ, he's a famous glitch hunter in the Pokemon community. Or maybe someone else. I'll put it in the description. But anyway, this is a RAM writer. So if we look at our spot in RAM here and go to DA80, this, and then let's look at where this is in our memory map, DA80. This is where our Pokemon are stored in our PC. So not our items, but our Pokemon. And look, this is a big spot in memory. And if we change any of these values, it's not going to break the game. Maybe if we go and try to withdraw one of those Pokemon or something, but that's not what we're interested in right now. We just want a big spot in memory where we can write a big payload. And I'll show you later, specifically all of these bytes here, which I'll show you what it does in a second. But we don't want to go beyond that. That can go into HRAM and that might start affecting things. But we have all this space now to write any arbitrary values into memory using this RAM writer. So we can press up to increment the byte, we can press left to multiply by 2, and then we can write it by pressing right. So if we look at DA80 in the hex in the memory viewer, we should see a 4A get written there if I press right, and boom, there's 4A. It goes to the next memory address. We can write a 2 there, and then maybe a 1, and a 1, and a 0, and a 0, and you see, whatever. But writing an entire program like this one here, that would take quite a while. So I've written this Lua script that can be run in BizHawk that will basically take this, convert those just to hex values for our payload, and then we have a function to do a joypad input, so we can do up, left, right, down, basically the controls of this memory viewer, and then we just use that to enter in this payload. So I'm going to exit out of the RAM viewer now, and then restart it. And then let's watch what happens in memory when I run this script. So we'll go into the Lua console in BizHawk, open up this program over here, the script that I've written, and run it. And boom, there we go. We're just going through all of these bytes in memory and successively writing them. And so you see it matches up here, 18, 1D, 18, 1D, and this is going to take a little while because we have a lot to write. So I just think this is one of the coolest applications of 8F, just to have a memory writer where we can arbitrarily write any values in memory and basically do anything if we have enough space in RAM to write a big enough program. Just such a cool application of glitches that have been found in Pokemon. Really fun to see how this all works in memory, to write a task tool to simulate the input, because this would be really cool to do by hand on an actual Game Boy. It's going to take a while. I think I will try to do that one day, but first wanted to see if I could get it working in the emulator, and it's just finished. So now it's written all of these data from DA80 onward, this whole payload here. Now we actually need to run that payload, we actually need to jump execution there again. But of course we can do this with 8F. We already know that carbos and X accuracy and TM33 correspond to a load HL and jump HL instruction. So we just need to change the quantities of carbos and X accuracy to, instead of where it is now, whatever it was, to jump to our PC, we need to tell it to jump to DA80. And rather than like tossing the items and maybe using the sing node to get the correct number of items, we'll just manually change this in memory to make it quicker. So this is at D322, and we'll just copy this item list. And if you take a look, make note, you'll see that the quantities change, even though we'll still have a carbos and X accuracy. So there, now it says we're going to jump to DA80, and if I exit our bag, we should see our quantities are different. It was 59 accuracies before. But now, let's see what happens if we use 8F to execute the payload that we used the RAM writer to put into where our Pokemon are stored, and see what happens. Here we go. And it's a little brick breaker kind of Pong style game. So again, I think this was written by ZZAAZZ, but it's very cool. And so this will just run forever, but we're playing a little mini game that we wrote using 8F and glitches within Pokemon. We made our own game within Pokemon, and that's just amazing. So that's about it. Thanks